In the previous introduction to Arduino video, I showed you how we could get started with using an Arduino board, starting up the Arduino IDE, connecting the Arduino board and loading the board with some example codes. In this video, let us take a look at the user interface of the program and learn about a few of many but basic code required to get starting with programming your Arduino. First up, when we open the software, we are greeted with this working space and a toolbar up top. There is the file drop-down menu which consists of all the software preference options, given example codes and folder for our project files. The edit drop-down menu allows us to edit the look of the code like changing the font size, etc. The sketch menu gives us the options to compile/upload the code and allows us to either use or manage the libraries which the Arduino community provides us. The tools menu has all the options of selecting the board we want to upload the code to and also for selecting different programmers for our microcontroller. We can see there are a lot of boards inbuilt in the program to select. And lastly, there is the help menu which we can use to inquire about the program. The code you can see here on the startup is called the bare minimum. If we compile this code, we can see there are no errors showing up. You might be wondering what is compile. Well, the microcontrollers used in Arduino boards are AVR based and they don't understand the C language we write the code in. So the IDE program converts the C language code into a language the IC can understand, and that is the assembly language. The bare minimum code has two functions which also tells us the microcontroller works in two states. As named, first state is the setup and the second is the loop. So if we delete these two functions from the code and compile it as a blank, we can see the compiler will show errors and won't compile it. This proves that the microcontroller architecture works in two states, that is first setup and second loop. So now let's write those two functions again and try uploading the bare minimum code. And as we see, the microcontroller does nothing because we haven't put in any command or code which tells it to do any sort of work. Now let's write a code only in the setup function or void, whatever you want to say. I prefer void because it gets easier for me to understand. The code only blinks a LED 2 times after uploading this code. We can see the LED just blinks 2 times and stops. Well, that's because the blink code we put in the setup function only runs once when the microcontroller starts up or resets. Then it moves on to the loop function. Now let's take a look at a few basic commands you need to know to get started. One of them is the pin mode command, which defines the pin number we put in first as an output or an input, regarding to what we write in the command. There is the digital write command which allows us to manually give a digital output, as the name suggests, on the corresponding pin as a high or low value. We can also use 1 or 0 instead of writing high or low. What the microcontroller does is it either provides current to the pin when set as high or sinks current when set as low. The delay command, as the name tells, enables us to introduce some delay in our code, and the value we put in is taken as delay in milliseconds. Now we write the blinking code again but move it to the loop function. The pin mode command only needs to be set up once, so we leave that in the setup void and set the LED pin as output. Now after we upload this code, which is also called sketch in the program, we can see the LED blinks continuously even after I reset the controller. This shows that the loop function executes from the top to the bottom continuously, hence the name loop. Now to demonstrate the use of delay command, if we change the delay from which the LED pin transitions from on state to off state, that is from 1 to 0, we can see the LED stays on for less time compared to earlier. Same way, if we change the time taken for the LED to transition from off state to on state and upload it, then we can see the change. Now let us take a look at the analog write command. As the name implies, this command allows us to output an analog signal on the selected few PWM pins on the microcontroller. This command will not work on any other than PWM pins. Now, unlike digital signals, analog signals are a variable voltage signal, so To create that, the microcontroller used in most of the Arduinos, which is the Atmega 328P, has an 8-bit DAC or digital to analog converter, which can output a total of 255 values, which the 8-bit word tells us. We know we have voltage input of 5 volts, so if we divide 5 volts by 255, we get 0.0196 volts per decimal value of the 8-bit DAC. This is called the resolution of the DAC. So if we want to find out, if we put in the analog write command to write out an 100 on an PWM pin, we can just multiply 100 by the resolution, which gives us 1.96 volts in this case. Now when I went ahead to practically test this, I noticed the value was way off. So I measured the input voltage and found my problem. Most of these Arduinos run at 5 volts and some at 3.3 volts. And I had the 5 volt one. But I was powering it with my USB hub connected to a phone, which was not able to provide enough power to the Arduino somehow. So I connected my power supply to provide 5 volts and tested it again, and it was accurate. Let's move on to the digital read and the analog read commands. Now when we have defined a pin as an input, the digital read command reads the voltage level at the pin and stores it in the memory as either a 0 or 1, hence digital read. Analog read, however, can only be used on the analog pins of the Atmega 328P or any other microcontroller. Atmega 328P has an ADC or analog to digital converter to read analog values with a resolution of 10 bits, hence 1024 values. Once again, we know the input voltage is 5 volts, and if we divide it by 1024, we get 0.004882. This is the resolution in terms of voltage of the 10-bit ADC. Now if we want to find the value the microcontroller will read, if we provide a 2.5 volt input, we can simply divide 2.5 by the resolution, which will come out as 512, which is practically similar. Now there are also two more commands, the serial begin and the serial print. The serial begin allows us to establish or open up the UART serial port to attach a UART device or monitor the controller on the computer. The serial print command allows us to write whatever we want on the serial port. So now if we test the digital read function and put the value on the serial port, we can see even without pushing the button we get a 1 on the screen. Well, that's because the input pin is floating when we don't push the switch. So to solve this, just put a 10 kilo ohm pull down resistor between the input pin and the ground and it will be fine. We can also put a pull up resistor between the input pin and the VCC, but we don't need to add a resistor externally to pull up the input pin. The microcontroller already has an input pull up resistor inbuilt of a 20 kilo ohm value, and to select it in the code we just have to add pull up after the input in the pin mode command. Now we can also use the microcontroller to do logical operations like AND, OR, NOT, NOR, NAND, etc. And to use them in this C based hardware code, they have symbols for each of them, like this double AND for the logical AND. I have written a code such that the LED will only light up when switch 1 and switch 2 both are pressed together, just like an logical AND gate works. For the logical OR, we have this double column symbol, which after using in my code and uploading it, the LED will light up when either of the button are pressed or both are pressed together, just like a logical OR gate works. I have created this template sketch to help you understand the basics and also help you to start writing your own codes. I will put the link to download this template in the description. If you found this video useful, then do like and share the video and subscribe to the channel for more videos, and don't forget to press the bell icon to receive future updates.